Hello everyone, welcome to our class today. We're going to go to section 8.1, systems of linear equations and two variables and applications. What I'm going to do is basically step through our slides and then I'm going to do our work over here on this side. Okay, so here are our learning objectives, concepts that we're going to go over. Identify solutions to systems of linear equations and two variables, which means we need to figure out what a system of linear equations and two variables are, solve those systems of linear equations, two variables, and then use systems of linear equations and applications. So what are we talking about when we are talking about linear equations, a system of linear equations and two variables? Okay, so when I'm talking about a system of equations, and I'm usually writing them in a little curly brace to let these know that these things are grouped. So I've got some system. Basically, I wrote there was an application where I needed to solve for certain variables. And they were actually two different variables that I had. Maybe cost revenue is something that we've looked at in the past. But here, somebody has written a system of equations, and it just says that 2x plus 6 times y is equal to 24. And at the same time, the same system that we had written the application about, x plus 5 times y is equal to 3. Okay, so what does it mean to have a solution of that? So basically what we're doing for a solution is to find some variable of x, some y, so this is like the coordinate, right? I'm looking at some coordinate where when I plug in the x and the y for both of these things, both of those check at the same time. Okay, so if I just looked at one thing, and if I solved, if I went here and said x plus 5y is equal to 3, and I solved for y like I usually, we would do a minus x, and we would get 5y is equal to 3 minus x, and then I'd want to get the 5 over there. So I'd divide both sides by 5. And I would end up with this. Well, that was basically a straight line, right? This is basically saying 3/5 minus x over 5, or 1/5 x. The slope is negative 1/5. Give me a value of x and I'll give you the value of y. Okay, so there's a whole, when I've got two variables like that, that's basically like a function. It ends up being a graph. So I've got something like, start at 3/5 and I'm going down with a slope of minus 1/5, and it would go something like that. Okay, so I have a whole set of solutions to that one particular one. But if I have two equations, then I may have something, if I went over here and if I solved the other one, 2x plus 6y is equal to 24, and if I did the same thing, I would get y is equal to 24 minus 2x over 6 minus 1/3 x with a 24, so I'm kind of looking up here, and eventually this thing is going to cross over, and there's going to be some point where those two lines intersect, and that would be the solution. That would be that x and y. That would be the same for both of these, okay? So this first example says, determine if the ordered pair is a solution. So what we do is just go back and look at that they're offering. So if we come up with a potential solution down here, if we did this for those, and if I said minus 3/5 is the solution, check. I have to go through and check both of these things. So let's go through and check and see if that particular point in space is a solution. So I go 2 times negative 3 plus 6 times 5. This is my x, there's my y. Does that equal to 24? And if it doesn't do the first one, then we're not even going to worry about the second one. So this is minus 6 plus 30, and certainly that's equal to 24, but that's just a solution of one. I need to check both. So here is my, if I label these as like 1 and 2, it checked for 1, and then I'm going to do the 2. So x, which is -3, plus 5 times my y, does that equal to 3? And I see that this 25 minus 3 does not equal, so it is not a solution. Okay, so let's try another one. Let's see if we can work on another one. So we're going to go back. We're going to rewrite our system, and I'm going to write it like you would normally see it. This would be a little curly brace, and you would have these coupled together to let you know that these are two equations that you want at the same time to be true. Okay, so let's check the point 2, -4. Okay, so I'm going to go up here. 3 times 2 minus a -4, does that equal to 10? 6 plus 4 indeed equals to 10. So the first one, but how about the second one? X, so let me get back. Our x is 2 minus 1/4 times -4. Does that equal to 1? So 2, there's our cancel. 2 plus, now the negative and the negative, that does not equal to 1. So that is not a solution. How about 1/3 and -9? So 3 times 1/3 minus a -9, does that equal to 10? That's just 1 plus 9, that's equal to 10. Now let's check the second one. Does 1/3 minus 1/4 times -9, does that equal to 10? So here we've got 1/3 plus 9/4. Does that equal to 10? And then we need to simplify to check this out. So I'm going to go 4 over 4 and 3 over 3. So that's 4/12 plus 27/12. Does that equal to 10? And no again. No. There's a 12. Okay. So let's do Desmos. Let's check Desmos real quick. Let's see if I can do this. 3x minus y is equal to 10. X minus y over 4 is equal to 1. If I drag this over here, eventually, if we get way down here where it crosses, and if I click on that, the -6, -28 would be the solution. And straight line, when I've got this doing straight lines, I'm expecting just one solution, x and y, if I get a solution. We'll talk about that in a minute. Let me go back here. How about if I did this one? I'm not sure if I did this one. Let's check here. I have bounced over. So if I've got 5x plus 10y is equal to 5, 22x minus 6y is equal to negative 3, and we're checking 0, 1/2. So for the 1, here's my equation 1, here's my equation 2. 5 times 0 plus 10 times 1/2, does that equal to 5? Well, that's 0. 10 divided by 2. That one works. How about this one? 22, 0 minus 6 times 1/2. Does that equal to negative 3? And that one works as well. So this is just negative 3. That again is 0. So for us, this would be a solution. And if I go back, now I'm just going to go back in and key into Desmos. Let's see how we do if we graph these things. Get rid of that one, get rid of that one. 5x plus 10y is equal to 5, just like I would expect. And then 22x minus 6y is equal to negative 3. Now if I go over here, hopefully there's going to be another, let's pull this down. There we go. So here I see my two lines, the two graphs of the equations, and where they intersect, they're both the x and the y is the same thing. That's what we're saying. We want that same point to be the same thing. And if I clicked on it and probably got there, 0.5 to 0, 1/2 would be the solution. Got it. How about our example 1 in Desmos? Let's go back over here. So click and click, click. 2x plus 6y is equal to 24. X plus 5y is equal to 3. And then we go over and it looks like they're going to be somewhere this way. And if I grab and slide, this would be the solution right about there. Looks to be about 25.5 and then negative 4.5, negative 25.5 and negative 4.5. Okay, so let's go back and continue where we were. Let me start over here. And then this is basically what I was telling you a while ago. Identify solutions to systems of linear equations in two variables. So if I graphed two equations and I get a solution, if I get someplace where they cross, these are straight lines, so I get one unique solution. That's what the graph will look like, and this will be the solution wherever these crosses. Here's my x, here's my y, so like this would be 2, 3, example. 2, 3 would be the solution of those, the system. Okay. So what about if I have something with no solution? This is one unique. If I have parallel, so here is my equation 1, equation 2, and if they're parallel, so these two, equation 1 is parallel to equation 2, I have no solution. What would I be expecting for here? Both of these slopes are the same. Here's M1, that would be M2, and M1 equal to M2. So they never cross. Parallel lines cross in infinity is kind of the geometry world. So no solution to this. Okay. Here's one unique. There's no solution. This thing is also called inconsistent. consistent. Consistent and inconsistent. Okay, consistent means I have a solution, and then inconsistent, I have no solutions. So there's no crossing. What about if I have something like this? So there's my 1 and my 2. I'm going to erase this. Small whiteboard today. What about if I have a system that looks like this? Y is equal to 2x plus 3. Okay, and that one's nice and solved out for us. And here I got 2y is equal to 4x plus 6. Let's go to Desmos and look and see what that looks like. So here I'm going to do my first one, y equals 2x plus 3. 2y is equal to 4x plus 6. And now if I go over and I look, so there's that one. If I go over, if I find, I need to go back this way. I only see that one line. And here I'm going to go and I'm going to click on this to make this one show up. There's that one. There's the green. See, neither one. I'm going to click on this one. There's what this one looks like. Cut it off. There's what that one looks like. They are the very same. Only thing I've done is multiplied this by 2. Okay, so basically if I took this and said 4x plus 6 divided by 2, this is the 2x plus 3, which is the same thing. They're the same line. So how does it give me infinite solutions? I go back here. Here's the words. This thing, infinitely many solutions, infinite number of solutions. These things are called dependent. Basically, it comes down that I have, it basically simplifies down. You have to give me an x, let's say 2, and then once you give me that x, then I can calculate y. 2 times 2 is 4 plus 3 would be 7. Excuse me. 3. 6 plus 3 is my 9. So I can continue this all day long. So those are the infinite number of solutions. Okay, they're dependent. So how do we solve these things? How do we get these things? Well, one way I showed you was with Desmos, you can graph them out and wherever they cross. Okay, but what about if we don't have those graphing, the graphing software available? Then we just do it analytically, and that's what we're going to talk about here. So there's a couple different ways that we can do it. Substitution and through substitution, and then elimination is what we're going to do. Okay. So substitution and then elimination, and they're just got the addition back here, but you're just going to add or subtract the other one. Okay. So for substitution, so our method is going to be substitution. And it just says basically solve, the easiest way to do is solve each for y and then set them equal. Solve each for y and then set them equal. So if I have something like y is equal to 2x plus 3, y is equal to minus x plus 7, I just set these equal. I'm basically substituting this for a variable. I could solve for x and then put it into here, and then I have to spend out. But this is, to me, is kind of like the easiest. If I solve for y, which we're used to doing as tools we've done in the past, and then all I just do is set these things equal. 2x plus 3 from this one is equal to minus x plus 7, and then I just solve like I've been doing all along in our class. Plus x plus x. 3x plus 3 is equal to 7. 3x is equal to 7 minus 3, minus 3 minus 3. And that's going to be what? 4. So x is going to be 4/3 dividing both sides by 3. Okay, so that's the substitution part of this. I can also do, it's called addition in that one, but it's basically elimination. I'm looking at taking two sets of these things, like 2x plus y is equal to 7, and let's say minus 2x plus 3y is equal to 5, and hopefully this thing would have a solution. If I basically add these things, but what I'm doing is looking to eliminate one variable by doing this. That's why the elimination. So if I just basically added everything, if I've got them all in line, this would be 0 plus 4y is equal to 12. Y would be equal to 3, both sides by 4, right? And then I would pick one and go and stick this back in. So let's just choose this one. 2x plus, there's my y, is equal to 7, and then I'm going to solve for x. 7 minus 3, and then my x is equal to 2. Okay. So let's see how we do this. Solve the system by using the substitution method. So here's my system. 3x plus 4y is equal to 5. X minus 3y is equal to 6. And by substitution. Okay. So I'm basically looking at solving one of these things for one variable and then sticking it back into here. Okay. So I'm going to call this 1, this 2. So let's solve for x. This is the easiest one here. So I'm going to solve for x in 2. X minus 3y is equal to 6. So x is equal to plus 3y plus 3y. I'm just moving it over there. 6 plus 3y. And now I put that into the other one. I don't want to go back to the original one. That's just not going to give me anything. It's just going to be an identity. Okay, so I want to put that into 1. This into 1. So 3x plus 3y is equal to 5. Distribute. It's probably the easiest way. And then I solve for y. Minus 18. And this is going to be what? Minus 13. And then I divide both sides by 9. Okay. Okay, so if everything went well into that one, whoops, I had this, oh, sorry. Let's stop this. Plus 4y. Sorry, I missed this. So distribute 18 plus 9y plus 4y is equal to 5. Now this should be 13y. Okay, and then I'm going to take and solve for y. So 13y is 5 minus 18. This was the negative 13 still, but now I'm dividing by 13. So this was negative 1. Okay, so I know my y is equal to negative 1. I'm going to go back and I'm going to put it back in, and look, I've already got this one had solved out as give me the y and I've got the x. So I'm going to use that back in here. So I'm just going to go x over to the side is 6 plus 3 times negative 1. 6 minus 3, and that's going to be 3. So my solution was, here's my x, make sure I've got my x first, and then there. 3 times 3 is 9, minus 4 is 5. And then I erased that one. That was the x minus 3y. 3 plus 3 would give me the 6 for that one. So here's one. Let's do the addition method. We could have done this here. Let's go ahead and do this one through addition. Usually sometimes it is obvious of which one you want to do. And then sometimes it's kind of your choice. Both of them is going to give you about the same amount of steps to get the answer. 5x minus y is equal to negative 26. Now, I don't like the term addition for doing this thing. I prefer elimination because there's actually a couple of steps before we do the final add. So here, if this matched, if this was just minus 3y or this was 2x, I'd actually want to subtract. But neither one, I can't get rid of anything just by adding the two of them. So I need to do something that comes in, that makes one of these look exactly like the other one. Okay. So here, this is kind of like the common denominator term. I'd have to multiply 5 here to turn that into a 10, 2 here to turn that, but I've got to do everything when I do any multiplications. This is the most obvious. So I would like to turn that 1 into a 3. So when I add them, I would like to have this being a negative 3y to go to 0. Okay, so I'm going to multiply everything here by that 3. So I'm going to turn this into 2x plus 3y is equal to 10. I'm just rewriting this system. And I'm able to multiply both sides, right? You're able to multiply both sides by the same thing, add the same number to both sides. But multiplication is going to be here, and I'm going to do 3. So 3 times 5, that's going to be my 15x. 3 times negative 1 is negative 3. And then 3 times negative 26 minus 78, like that, okay? And now, all I'm going to do is add. The add, because this one's a different sign. If this was a plus and a plus, I would want to multiply both sides by a negative 1 so that when I add, I get the result. 17x plus 0y, 3 minus 3, is equal to 10 minus 78 is minus 68. And then I just get my 68 over 17. And that's my negative 4. Okay. So now once I have my x, I need to put it back in here. This looks like it would be the most obvious to do. So I'm going to go 2 times negative 4 plus 3 times y. I don't know what the y value is yet. And then I solve this for y. This is negative 8, so I'm going to add plus 8 to both sides. 3y is equal to 18. And my y is just going to be 6. So the solution to this, the original one, is just negative 4, 6, like that. And then I'm going to leave it up to you to do as a quick check and make sure it works for both of these things. Okay, so here's a couple of skill practices. Those are just like we did. Sometimes we end up with a lot of decimals. How do we do these? I'm going to show you kind of a way to scale them so I don't have to do decimals. You'll see this frequently. Let me get a little better Sharpie. 5x plus 0.3y, that's going to be 1.4. And then 0.2x minus 0.1y is equal to 0.28. A trick if you don't want to deal with decimals. you can just pick whichever thing and then multiply that, whatever that decimal is, to get rid of all of these. So if I multiplied everything by 10, that would get me to 2.8, and if another 10 would be 28. So I can multiply both sides by 100 and get the answer here. So this is 0.2x. If I multiply this by 100, I would get 2 and then 20x minus 110y for the 100 and then to 28. And I can multiply this just by 10 because I've only got one decimal. This is times 10. And I could have 50x plus 3y is equal to 14. So that's one trick you can do if you don't want to deal with a lot of decimals. Just go ahead and get rid of your decimals by multiplying times 10 to each time to get rid of one side, and then you can work with them. Okay. So solve this. That's just one method or one step to remove decimals. If you don't want to deal with a lot of decimals. Okay. Let's see. Would that help us anything here? 814. 0.3. This was 0.3 to start with. And I'm going to 10. So let's do, I want to do substitution. The reason being is that neither one of these are like an equal power, so I can turn this in and give it to me. Hold on. Did I get this? Point y. This is supposed to be 30. Okay, it's to 3. Ten times this, 10 times this, and then 10 times that. So let's do substitution. Let's solve this one for y. So I'm going to go 50x plus 3y is equal to 14 for my y. 14 minus 50x over 3 to make a long story short. And then I would substitute this one back into here. $20x minus 10 times my y is 28. And then this kind of gives me, I'd like to get rid of this 3, so I'm going to do both things by 3. Both sides by 3 to clear up my fractions. Remember how we did that when we were dealing with rational expressions? So this is just 60x minus 10, 14 minus 50x, 3 times this, 3 times here, but once I do the 3, I cancel there. And then I have my 24, 84 over there. I solve. Okay. And then I basically get my minus 440x to get rid of those. And then plus 140 on both sides. 412, 224. And this looks, again, negative 224 over 440. $58, 28 over 55. And then I would go and plug that back into the other one. Okay. So let's do back into the first 20. Let me get rid of this. Hopefully I've got up to this so far. Minus 10y is equal to 28. And then I would solve that for y. Okay. And I want to move, got my 28 minus this over here. And then divide by that negative 10 to make a long story short. And minus 98 over 55. So fractional, if you wanted to do the fraction, this didn't come out very nice in the decimals. Let's go through, let's keep the decimals. Let's keep this without reducing them and see if we've got some small numbers that we can deal with. And we're just going to use decimal numbers as solutions. So here's another way, instead of going through all that with fractions, let's just turn this 0.1 into 0.3 and do elimination. Okay, so again, 1, 2, I'm going to take 2 and multiply times 3. So all of this times my 3. 0.6x minus 0.3y is equal to, again, we're going to do the 3 times my 0.28, and my 3 times 0.28, again, is going to be the 0.84. Okay. So now I can do the 5x plus 0.3y is equal to the 1.4, and I'm just going to add and use my decimals through here. Okay, so this is 4.4x is equal to 1.4 plus the 0.84. .24, x is equal to 2.24 over the 4.4. 4.4, and then 0.509. 0.51 would be my x, and then I'd go back and solve for my y. Okay, so my 0.3y, this is 5 times 0.51, 2.55. So this is minus 2.55 minus 2.55. Minus 1.15, and then my y divided by 0.3, negative 3.83. 83. Okay. So if you pick that up, that was certainly much easier just leaving it in decimals, even though it looked like it would be better if we kind of went through. Okay, so let's move on. Solve this. I'm going to let you kind of go through, work on the example 6, example 7. Those are solutions or in the part B of the slides. So you kind of work those through. Here's the skill practice. I want you to go through these skill practices. Look at the Word document. You'll see something very similar, and come up with the solutions for that. And we'll go. You turn those in for us on Monday.